Hi everyone, Dr. Mike here. In this video, we're taking a look at liver physiology. The liver undertakes over 100 different functions, and in this video, we're taking a look at every single one. Well, maybe not all of them, but we're going to go through the most important functions of the liver. Let's take a look. All right, to begin, we need to understand that the liver is the largest organ inside of the body. It's sitting in our abdomen in the upper right quadrant. And like I said, it undertakes many different functions. But to understand all this, we need to begin with its blood supply, because the liver has a blood supply unlike any other organ of the body, and I'll show you what I mean. Firstly, let's orientate ourselves. We have our heart, and we know that the major artery that leaves the heart is the aorta. So we are imagining in this diagram that the aorta has exited the heart and it's gone through the thoracic cavity, through the diaphragm, and has now entered the abdominal cavity where our digestive organs, including the liver, reside. So we can label this our abdominal, let's just write aorta. And we know that the aorta will, or at least the aorta coming straight out of the heart, will be pumping out 5 liters of blood every single minute. That's what we call our cardiac output. Now, of this 5 liters, once it's in the abdomen, how much gets sent off to all the different viscera or digestive organs of our digestive system? Well, firstly, there's 3 major branches of the abdominal aorta that feed these digestive organs. These branches include that of the celiac trunk, include the superior mesenteric, and the inferior mesenteric artery. So we've got the celiac trunk, the superior mesenteric artery, and the inferior mesenteric artery. What organs are they feeding? Well, they're sending this nice oxygen-rich blood to the liver, to the spleen, to the stomach, to the pancreas, to the small intestines, and to the large intestines. And of this 5 liters of blood that's going through the aorta, entering the abdominal aorta, around about 700 mils will go via the celiac trunk. Around about 700 mils will go via the superior mesenteric, and around about 400 mils will go into the inferior mesenteric. Now, of this 700 mils, importantly, around about 300 to 500 milliliters every minute, right, will enter this vessel here. And this vessel is called the hepatic artery. Hepatic artery. So you've got the hepatic artery giving 300 to 500 mils every minute of blood to the liver. And this is going to be oxygen-rich blood with nutrients inside. But here's another really important point, right? This blood is going to all of these various structures to give them oxygen and nutrients and so forth. But what we know is that a lot of these structures will also drain into veins, and they all drain into the one vein. What is this vein? This is called the portal vein, importantly. So this is the portal vein. Now, this portal vein will be sending, as you can see, the portal vein is going to be collecting all of this blood, and it sends it to the liver. And how much? Well, it's around about 1,000 to 1,500 mils every minute. Look at that. The liver is receiving, this is the important point, the liver is receiving 2 different blood supplies. No other organ receives 2 different blood supplies but the liver. The portal vein is really high in nutrients, right? Really quite high in nutrients and quite low in oxygen. But the hepatic artery is high in oxygen and, quite high in nutrients. Now, that's a lot of blood. That's nearly 1.5 liters of blood-ish, or around about 1.5 liters of blood going to the liver. That's a huge amount. Now, importantly, you can see that the portal vein constitutes 75% of the blood that goes to the liver. So think about that. All the organs get fed by arteries, right? And that's 100% of their dedicated blood supply. But the liver, it's only around about, what's that, 25% of its blood supply comes from the hepatic artery, right? 75% comes from the portal vein. During a meal or postprandial, just after a meal, that can go from 75% up to 90%. So the liver gets 90% of its blood after a meal from the portal vein that's draining from all these various organs. Because remember, these organs are absorbing things and then secreting things, and they're dumping it into the portal vein. Okay, so that's the first important point we need to highlight, those two different blood supplies. Let's very quickly talk about some of the functions of the liver, because it relates to what we've drawn up here. So what are the various functions of the liver? Well, like I said, there's hundreds. There's well over 100, right? One is going to be one that not many people talk about, which is blood storage. And that's one of the reasons why I've drawn this image up here. Blood storage, very important one. Another important one when it comes to the liver is filtration and detoxification. It also undergoes metabolism. It creates proteins, synthesizes proteins. So protein synthesis, right? Regeneration. And very importantly, can't forget bile synthesis. It creates bile. Bile is like the detergent that our body produces to help break down fats through digestion. This is a list of some of the most important functions. So let's first start with blood storage. The liver can store around about 450 mils of blood at rest. So it can store 450 mils at rest. That's nearly half a litre of blood stored in your liver, in the sinusoids and hepatic veins. See, these are what we call the hepatic veins, right? They come together, these hepatic veins, they come together and enter in what's called the vena cava, right? And that vena cava will then go back to the heart. Half a litre can be stored in these liver veins or in the sinusoids, which I'll talk about shortly, of the liver itself. Really important. Now, let's think about this, right? If the heart, remember the heart's got a left side and a right side. If the right-hand side of the heart poops itself, stops working, that's called right side heart failure, what do you think happens to this blood? This blood ends up backing up. Now, if this blood backs up, it's going to back up into the veins of the liver and into the liver itself, which means the liver can go from storing 450 mils at rest to storing more than 1 litre of blood when it comes to right side heart failure. So let's say right side heart failure. Important point, very important point. So the liver swells, and that's called hepatomegaly. So you can get what's called congestive hepatomegaly as a result of right side heart failure. We're going to talk a little bit more about some of this in a second. So that's its role with blood storage. What about filtration and detoxification? We're going to talk about that in a sec. Now, here's an important point. I've done a video on metabolism and bile synthesis, and you'll see those as links in the description. They are longer topics, so otherwise this video would go for over an hour. We don't want to do that. Feel free to watch those videos in the link provided in the description, but we're going to go through filtration, detoxification, protein synthesis, and regeneration in this video. All right, let's talk about filtration and detoxification. To do that, we need to understand this hexagonal looking thing here. 6 sides, 1, 2, 3, 4, 5, 6. All right, this hexagon is what we call a liver lobule. A liver lobule. So if we were to draw the liver up, right? All right, so there's a liver. Remember we said you've got a blood supply entering here and another blood supply entering here. Do you remember what they were called? This one's going to be called the portal vein. And this one's going to be called the hepatic artery. Hepatic artery. And remember, you're going to have the hepatic veins leaving as well. Let's just write that up for completion's sake. Hepatic vein, which ultimately goes into the vena cava. Inside the liver, you've got these hexagonal shapes, and they're all connected to each other like this. Isn't it beautiful? So you've got all these hexagonal shapes, and they're called liver lobules. And there's around about 50,000 to 100,000 of these liver lobules per liver. They contain, these are actually the functional units of the liver, right? And they contain the important cells of the liver called hepatocytes, which I'm going to show you in a second. So what I want to show you here is this. There are going to be branches of the portal vein, and these branches will go to the corners of every single one of these lobules, right? So see how there's going to be 6 corners? You're going to have branches of the portal vein that goes to every single one of them. That's interesting, right? The same thing happens with the hepatic artery. You're going to have branches of the hepatic artery going to the corners of every single one of these lobules as well. All right, that's also interesting. So I want to draw that up here on this lobule. So we're going to have hepatic artery at every corner, branch of the hepatic artery. We're going to have a branch of the portal vein at each one of these corners. And we're going to talk about what happens, because this is blood entering, remember? This is blood entering the liver, entering the lobules. So these lobules contain what's called sinusoids. Sinusoids. So the sinusoids look a little bit like this. There we go. These are our sinusoids. So in here, these are the sinusoids, and that is what we call a central vein. Because what happens is, in every one of these sinusoids, the portal vein will mix with the blood of the hepatic artery. It mixes inside of this sinusoid, right? Perfect. Mixing. And here's the thing. The sinusoid contains epithelial cells, endothelial cells, right? So you can rub this out like this because they're epithelia with gaps between them, right? So you could do that all throughout. And this is important because this is what makes it sinusoidal. Remember when we spoke about capillaries in another video, there's different types of capillaries. The capillaries that have the largest holes in them are called sinusoidal. Now, these are what we call sinusoidal, these are sinusoids, and these are sinusoidal epithelia, which means they're big gaps, and they let heaps of things through. They don't let cells through, right? But they do let proteins through when other capillaries do not let that happen. So you've got both the hepatic artery and portal vein mixing blood, and you've got these sinusoidal, let's label them here. Let's sinusoidal epithelia, or you could call them endothelia, right? And they're going to let some things through. So the blood's getting pushed through either side, on both sides, right? So that blood gets pushed through. Now here's another really important point. Embedded between these endothelial epithelial cells are some other cell types, right? There's heaps of them. And these cells are called Kupffer cells. What I'll do is I'll draw some here so I can label them. So I've got these cells along here, right? And they're called Kupffer, Kupffer cells, and they're basically like macrophages, big eaters. What is their job? Well, Think about this. If you're draining blood from the small intestines and large intestines, there's a lot of bacteria in there. And that bacteria, even though we don't want it to, can actually get into the portal vein. And that bacteria in the portal vein goes into the liver. And if it gets through the liver and goes to the heart, it's going to be in the systemic circulation. You don't want bacteria in your systemic circulation. They can make you quite sick. So the liver needs to play an important role of killing off any invading pathogens. That's what these, that's what these Kupffer cells do. They kill off invading pathogens. That's why they're macrophages. Within 0.01 of a second, they will have grabbed onto, engulfed, and destroyed any invading bacteria and pathogens. And the result of doing so means that less than 1% of the bacteria that gets taken through the portal vein makes it into the systemic circulation. You might think, that's still too much, but that's okay. We have an immune system that can attack and destroy and hopefully get rid of all of that bacteria. So the Kupffer cells are important. That's part of that filtration process, Here's the other thing. We haven't even spoken about hepatocytes. So in this space here, you've got these plate-like hepatocytes, right? So they're going to be here. So hepatocytes are very plate-like. Oh, I just accidentally drew that inside of a sinusoid, like the fool I am. My apologies. Let's draw it up here. There we go. Let's draw another one here. Okay, so they're obviously going to be all the way throughout. These are the hepatocytes, right? Now, here's the thing. The blood that gets pushed through here, makes it past the Kupffer cells, can go to the hepatocytes. Now, what do the hepatocytes do? Well, they do the metabolism, right? They do the protein synthesis, right? They can do detoxification. They do bile synthesis. They're involved in regeneration. So they're very important. So if they're producing, let's say, proteins, they'll throw them back out in the direction that it came in. Beautiful. But what they also do, interestingly, is this. They actually also produce the lymph, right? Lymphatic fluid. So it can produce lymph, and this lymph fluid, I'll write lymph here, right? That's important, lymphatic fluid. But it also has these little, what's called bile canaliculi. So the hepatocytes can produce bile, and they end up coming together in like these bile vessels. And these bile vessels end up draining into another duct or vessel. This is the bile duct, right? So the hepatocytes are producing bile and draining it here. So we've got three things. Portal vein, hepatic artery, bile duct, the lymph is not included here, and all three of these things here is called the portal triad. The portal triad, very, very important. So there are those hepatocytes produced. Now, some other important points here, right, is while that's part of the filtration process, the Kupffer cells, detoxification can happen in the hepatocytes. Now, how does this happen? So the hepatocytes undergo what's called xenobiotic metabolism. Xenobiotic metabolism uses many different enzymes. One of the important enzymes is cytochrome P450. And what it effectively does, it has two stages. And the stages are very similar. Basically, the whole point of this is to take a toxic compound, and one, it wants to detoxify it or make it less toxic, and two, make it less lipophilic, so less fat-loving and more water-loving, because the less fat-loving it is, the less likely it's going to get pulled into cells. The more water-loving it is, the more likely it's going to be pooed out or peed out. So pooed out through the digestive tract or peed out via the kidneys. That's what this two-stage xenobiotic metabolism does, and that's what's happening inside of these hepatocytes. That's that detoxification process. Now, the protein synthesis, right? So the hepatocytes are also going to be producing proteins. Now, probably the most important proteins you need to know are those of albumin, right? And those of the clotting proteins. Now, I've done an entire video on clotting proteins, so I suggest you watch that. Type in clotting cascade. I'll talk everything about the clotting proteins, but effectively, they ultimately want to produce something called fibrin, thrombin and fibrin, and that allows for us to form a clot when we're bleeding. Albumin is the important one here. So it's going to, let's say these hepatocytes produce albumin. It will dump it here into this space. Now, I haven't actually told you, but this space here, right? So the space between the sinusoidal endothelial cells and the hepatocytes, this space here is called the space of Dicey. It's got a name, just thought I'd let you know. So the albumin will be dumped into the space of Dicey, and then the albumin will be thrown back into the sinusoid, right? And then will drain down into the central vein. Where does the stuff that gets drained into the central vein go? Into these hepatic arteries, which ultimately go back to the heart and then through the systemic circulation. So why do we need to understand this? Well, let's think about some very important disease states. Cirrhosis. So the liver's getting damaged, generally due to chronic alcohol abuse. Somebody's drinking too much alcohol, it's damaging the liver. This scar tissue forms. What do you think happens? Well, if scar tissue forms, think about the hepatic artery and portal vein that's entering. So think about it like this. The liver now is, in a way, not working properly. It's off limits. So you've got this blood supply that's coming in and this blood supply that's coming in. Which one is the high flow? This one, the portal vein. So you can think about the portal vein as being basically the pressure in this portal vein here coming through. It's around about 9 millimeters of mercury at rest, right? Consider that with the aorta. The aorta's, anywhere up to 120 millimeters of mercury. So it's low pressure but high volume. Now, if the liver's off limits because you've got cirrhosis, this blood backs up. Now, it's different to when the heart fails. That's backing up after the liver. Here it's backing up before the liver. So all this blood, I'm going to get rid of this here. This blood is backing up in the portal vein. So think about it backing up. It's going to back up into the spleen. It's going to back up into the stomach. It just keeps backing up into these tissues. Now, what ends up happening here is that the blood ends up leaking out of the portal vein into the abdomen, into the peritoneal space. So you now get fluid in the peritoneum, right? Into that peritoneal space. And you get what looks like abdominal distension, swelling. That is what we call ascites. So that ascites is that abdominal swelling due to fluid accumulation in the peritoneum. That's happening because the blood pressure has gone above 9 millimeters of mercury. It can go to like 15 millimeters of mercury, right? That's what we call portal hypertension. So you can have cirrhosis, which leads to portal hypertension, and that portal hypertension leads to fluid in peritoneal cavity, which is what we call ascites. Now, if this is happening because of liver damage, fluid always leaves blood vessels and goes into the interstitial area, but it gets dragged back in. Why does it get dragged back in? Because of albumin, because we produce this albumin. Remember that in a capillary bed, right? Let's say this is a capillary bed. There's holes in that capillary. And here are some cells I want to give nutrients to. The blood's entering, right? There's a blood pressure and the blood leaves, or at least some of the blood fluid leaves because of the pressure. So it can give oxygen and nutrients to these tissues. But because now fluid has left the blood vessel, we don't want to lose all that fluid, otherwise we'll lose all of our blood pressure. So on the other side, the venous side, we need to pull that fluid back in. How do we do that? We do that because of the negative charge of albumin. That negative charge albumin has an oncotic or an osmotic pull, pulling it back in. So the whole reason why we maintain blood fluid or blood volume in our blood vessels is because of the negative charged albumin. But if we have cirrhosis, that albumin will not be produced because we've got damage of the liver. No albumin being produced, we can't pull that fluid back in. So the fluid continues to accumulate and that ascites gets worse and worse. And it doesn't just happen here. If you've got no albumin, that fluid accumulation is going to happen in your peripheries, in your legs and in your arms, for example. And that's called edema. So ascites here in the peritoneum, but edema everywhere else. So you can see that with the liver, it plays so many different roles. Now, regeneration, that's important. The liver has the capacity to regenerate, so you can remove a significant portion of the liver. And thankfully, these hepatocytes allow for us to stimulate, turns on certain transcription factors and certain enzymes, and allows for the liver to regenerate a significant portion of it because it's so damn important. All right, I think I'll leave it there. That is liver physiology, and I'm Dr. Mike. Hi everyone, Dr. Mike here. If you enjoyed this video, please hit like and subscribe. We've got hundreds of others just like this. If you want to contact us, please do so on social media. We are on Instagram, Twitter, and TikTok at Dr. Mike Todorovic, at DrMikeTodorovic. Speak to you soon.